I personally find this question to be a little bit annoying because we're given an incomplete set of numbers, right? We know some of them, 7, 9, 6, 4, 5, but there's one missing value called x. Now the question is asking us to find the median of this set, so where my mind is going is, would it be at all possible to find the median of the set without knowing the value of x? And the answer to that is yes, it would be possible. That's kind of the beauty with a median, is that you could find the median without knowing all of the values as long as you know the order of the values. So if I knew that x is very small, then I would know that it goes on the left side of the list, and the middle two numbers would be 5 and 6, which would then mean that the median is 5.5. If x was very big, then it would go all the way to the right side of the list, and then the middle points would be 6 and 7, and the median would be 6.5. So by knowing kind of directionally where x fits in the set, we could possibly be able to find the median without knowing the exact value of x. I think that's really the concept that's being tested in this question. So let's go ahead and evaluate the statements right after this. So I think statement 1 is easier to evaluate in this case because it kind of fits one of the scenarios that I was describing earlier. If we know that x is to the right of 7, then for sure 6 and 7 are the midpoints, the two middle points of the set, and therefore we can find the median. It would be 6.5. So statement 1 is sufficient on its own, and we can go ahead and eliminate the answer choices that claim otherwise. So B, C, E, all gone. Now, statement 2 is a bit more challenging to evaluate because it's talking about the mean. The mean of this set would be the sum of the 6 terms divided by 6. But we don't know what the terms are. Well, we know 5 of them, but we don't know x. So if we wanted to write out the mean algebraically, we'd have to add up the numbers that we do know about, plus x divided by 6. So that's 31 plus x over 6. That's the mean. We're told the mean equals the median, but does this determine which side of the set x is on? Or could x still be a small number and a large number? Well, let's imagine that x is a small number and the median is then 5.5. Well, is that possible? What would x have to be for the mean to be 5.5? I think the fastest way to check that would be the balloons and weights method. And we can see there that in order for the deviations from 5.5 to balance out, x would have to be 2. Well, that fits the bill. If x is 2, the median and the mean would be 5.5. On the other hand, if we wanted to check whether x could be a large number, which would then mean the median is 6.5, can that happen? What would x be if the mean is 6.5? Again, using the balloons and the weights, we can see that if x is 8, that fits the bill. If x is 8, then the mean and the median are both 6.5. So with statement 2 on its own, we can't determine what the median is. It could be 5.5, it could be 6.5, as we just saw, and therefore the correct answer is A. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.